Welcome all of you to this video of Maths Made Easy. Now in this video today we are going to do is matter around us pure. Okay, so we are going to do this chapter where we are going to know about elements, compounds and mixtures. Okay, so let us start. Firstly, what are pure substances? Okay, pure substances. Now pure substances are made up of can either be elements or they can be compounds. Okay, these two things make up pure substances, elements or compounds. Okay, these make up pure substances. Now in elements we have a whole lot of elements, like supposing iron, sodium, sulfur, oxygen, hydrogen, nitrogen. Each one is an element. Okay, compounds we have FES. Just giving an example, there are many more examples. Water, so there is FES, water, you can say HCl, hydrogen chloride, all these are compounds. Now what is the basic difference? Okay, now what is the basic difference? Why are they called elements or why are they called compounds? Now when we have oxygen, iron, sodium, sulfur, hydrogen or nitrogen, how are they different? Now every element has electrons, protons and neutrons. Okay, in the outer shell they have the electrons, inside in the nucleus they have the protons and the neutrons. Okay, now different combinations of electrons, protons and neutrons. That is, iron will have one particular combination of electron, proton and neutron. Oxygen will have another combination, electrons, protons and neutrons. In itself they are all same. There is no difference between one electron from iron and one electron from oxygen. But the number of electrons in oxygen, in all oxygen atoms, is same. The number of electrons in all iron atoms is going to be same. Similarly, the number of protons in all iron atoms is going to be same. The number of neutrons in all iron is going to be same. So when these combinations of the same combinations of electrons, protons and neutrons, they become one element. Okay, so they become one element. On the other hand, here compounds are made up of two different elements. We can see here it is made up of iron and sulfur. This is made up of hydrogen and oxygen. The other one is made up of hydrogen and chlorine. So these are made up of two or more number of elements. Okay, so a compound will be made up of two or more number of elements. Now this is a pure compound, that is all the pure substance, that is also a pure substance. Now here if I see the electrons, supposing there is one Fe atom, then it is the entire, you have 2 grams of iron, let's say, then it is, these are all Fe atoms, one after the other. This is, so you can see this is only made up of iron, which is again pure. Okay, that is why it is termed as pure. Only oxygen, supposing you have 2 grams of oxygen, they all are oxygen atoms. Okay, full of only oxygen atoms. Each one is an oxygen atom. That means each one has a particular combination of electrons, protons and the same combination of electrons, protons and neutrons. So same for all of these. Now if you say compounds here, these two are in combination. So here one iron, one sulfur. Again one iron and one sulfur. Okay, one iron and one sulfur, like this. So if I take 5 grams of FeS, the full thing is made up of combinations like this, one iron, one sulfur. There will not be anything else. That is very important. There will not be anything else. Here if I see hydrogen and oxygen, one oxygen and two hydrogens, one oxygen. Okay, again one oxygen and two hydrogens. So entire water will be made up of molecules like this. Now there will not be anything else other than this. That is why again it is a pure substance. Okay, when I do mixtures, then you will know why mixtures come under impure substances. Okay, Now, when I take up this, uh, when I talk about only elements, okay, when I talk about only elements, then in elements you have four types. Actually, four types. One is a metal, okay, then you have a non-metal, you have metalloids, and then you have noble gases. Noble gases, or also called inert gases. Okay. Now in this metals you have sodium, potassium, calcium, magnesium, iron, okay, He, that is mercury. I'm giving few examples: zinc, copper, silver, gold, all these are examples of metals. There are more, okay, I have given only a few. Non-metals are hydrogen, oxygen, nitrogen, chlorine, fluorine, iodine, okay. Then you have sulfur, carbon, phosphorus. There can be many more. These are non-metals. Come to metalloids, then we have, now metalloids we have arsenic, boron, germanium, okay, boron, germanium, arsenic, okay, these are all, there are many more, these are all examples of metalloids. Come to noble gases, we have helium, argon, xenon, radon, krypton, okay, all these, there are six of them, six noble gases we have here for noble gases or inert gases. Now let me tell you what is what. Metals are the ones which have, we are going to discuss the properties of metals and non-metals. Metals are generally the ones which are solids. There's only one liquid metal which is mercury. Okay, other than that these are solids. Okay, non-metals generally these are solids or gases. The only liquid non-metal is bromine. Now they have some properties, I am going to talk about that in detail, so I am not taking it up now. Next I am going to talk about it. Metalloids are things which have the properties of metals as well as non-metals. That makes them metalloids. So they are kind of an intermediate. They have the properties of this as well as this. Okay. Noble gases is something which is neither metal, non-metal or metalloids. It is completely different. It does not react with anything. This is generally found in the upper layers of the atmosphere, okay, and does not react with anything. Okay, that is why it is called inert or noble gases. Okay, now let us talk in detail of what is it, what is a metal and what is a non-metal. Now what are metals and what are non-metals? Firstly, metals are substances which are sonorous. You have done it. Sonorous means they have that typical metallic sound. Okay, so if they are bent, they will give you the typical metallic sound. Non-sonorous, they don't have that sound even if they are solids, non-sonorous. Metals have that luster. Okay, luster, that is they have a metallic shine, like gold will have a shine. Okay, silver will have a shine, even iron will have a kind of metallic shine. Okay, this is non-lustrous, no shine. Okay, even if they are solids, they are powdery kind of, absolutely no shine. Now there will be some non-metals which still have shine. Exceptions are there, non-metals which are having shine. One is graphite, that has a shine. Another is iodine. Okay, iodine is found in crystals. So these are, in spite of being non-metals, they still have shine. Okay, let's talk about these are malleable. Malleable means you can beat them into sheets. We can make copper sheets, we can make iron sheets, we can make gold sheets. Okay, that is malleable. And non-malleable, these are cannot be made into sheets. If you beat some non-metals, they will only become powder. They will not be able to make sheets out of them. Ductile. Metals can be made into wires. You know, for gold, they make thin gold wires or copper wires. Okay, all our electricity is run through copper wires. So you can make wires out of them. Here, non-ductile, not possible to make wires. Let's come to high melting point and boiling point, low melting point and boiling point. Okay, then these are good conductors. Metals are always good conductors of heat and electricity. Okay, and electricity. Non-metals are bad conductors of heat and electricity. Okay, of course there are exceptions. Okay, graphite, in spite of being a non-metal, is a good conductor of electricity. So graphite is used in many graphite electrodes are made out of graphite. So graphite is a good conductor of electricity even if it is a non-metal. So these are few of the differences between metals and non-metals. Now you can easily say what exactly makes a metal, why, if, and what exactly makes a non-metal non-metal. Now these are, remember, these are physical properties. Okay, these are not chemical properties. If you start seeing chemical properties, these are oxidizing agents, these are reducing agents, these give electrons, that take electrons. So there will be many more like that. So as of now in this chapter, in 10th standard, we learn the chemical properties. Here we are learning only the physical properties. What are physical properties? The properties that are easily visible. Okay, so that those color, shape, texture, melting and boiling points, these things come under physical property. Now till now, more than 100 elements have been discovered. Okay, out of which 92 are naturally occurring. Now these things come in MCQs. 8 are man-made. Okay. Now majority of this is solids. This is the only liquid metal, and bromine is the only liquid non-metal at room temperature. Okay. Now there are two elements, gallium and cesium. These two elements are generally solids, but then at a temperature which is little higher than room temperature, they melt and go in the liquid form. And that is the reason if you keep them on the palm of the hand, the palm is slightly warmer, it melts on the palm of the hand. Okay, so these are two, you can say, exceptions. Now let's talk about compounds and mixtures. Okay, let's talk about compounds and mixtures. Now compounds are substances, we talked about it. Like I said, this is iron and then with it one sulfur, one iron and one sulfur. Like this, these make compounds. Okay. But if we make mixtures out of iron and sulfur, if we make a compound out of iron and sulfur, they will be in a chemical combination. So they will be together. For every one iron, there will be one sulfur atom. For every one iron atom, there will be one sulfur atom. Here in mixtures, iron and sulfur mixture will be like this. Sulfur, iron, sulfur. Okay, more iron and sulfur. Now what is this happening? Okay. So compounds have a fixed composition. Means what? They have a fixed composition. What does that mean? That means for every one iron there is one sulfur. If we take water, for every one oxygen there will be two hydrogens. Okay, that will make water. If I put 3 hydrogens, firstly I will not be able to put. Okay, second thing, 3 hydrogens and water can make a different compound altogether, but it will not make water. Okay, so here no fixed composition. Now here I want to tell you, supposing you are making sugar solution, that is a mixture. That is, you are mixing sugar into water. If you mix 1 spoon of sugar in a glass of water, it's a mixture. You mix 5 spoons of water in a glass of water, that too is a mixture. So the no fixed composition. So you can see there are 2, 3 irons here and there are 5 sulfurs. You can put in more sulfur, you can put in more iron. but the thing is they will not enter into a chemical composition, they'll be separate. To make them enter into a chemical composition, you have to go through some other chemical reactions, maybe heat them, or sometimes pass electricity through them, depending on what are the components. Okay, and then only you will get a particular compound. So mixtures are just few things put together, and where the things don't react within themselves like this, they are all separate. Okay, like mixtures. Another thing is, if I see mixtures here, iron is that grayish black in color, here this sulfur is the yellowish in color powder. So you can see them separately. Okay, you can see the iron separately, you can see the sulfur separately. So generally you are mixing water and sand, you can see the sand separately, you can see the water separately. Okay, but here iron sulfide, they combine, and you can't see the color of iron separately and the color of sulfur separately. Together they take one particular color which can be different from the color of iron and sulfur, and they have completely different properties from that of iron and sulfur. Okay, so this will have completely different properties from that of iron and sulfur. Here these will have the properties. Iron will have that magnetic property. If you hold a magnet over it, it will be attracted to it. So here they retain their properties. Similarly, if I say here hydrogen and oxygen are two gases and they have their own properties. Okay, they have their own properties, but then when made into water, they have completely different set of properties. Now just by seeing, you can't even say that it has been made out of hydrogen and water. Okay, because the properties have completely changed. You don't see the hydrogen separately and the oxygen separately anymore. Okay, this is easily separable. There are different methods. You can maybe heat them, use a magnet, you can pass them through a sieve, you can filter, some might be water soluble, other one can be filtered out, things like that. There can be different methods of separation of mixtures depending on what is the mixture. Okay, here you don't have not separable easily. Okay, next is a new compound. That means, what I mean by this is completely different properties. New compound is formed. Okay, no new compound. Just an example of sugar and water. Maybe you can't see the sugar separately because sugar dissolves in water completely. You can't see salt separately because salt will also dissolve in water separately. But then you will be able to taste the water separately and the sugar separately if you taste it. You can taste the salt separately and the water separately. So they retain their original properties even in the solution. Solution is a mixture. Okay. Now there are two types of changes. Okay, one is physical and one is chemical changes. Let's talk about that. Physical and chemical changes. Here the composition of the substance does not change. Okay, does not change. Here the composition changes. Now what are physical and what are chemical changes? Composition changes. Now what is it? In physical changes are very simple changes like heating water and boiling water is a physical change. You cool it down, you get back your water. You form steam by boiling and evaporating water. Condense it, you get back the water. Okay, so these are all physical changes. Okay, whereas in chemical changes, growth of a tree, burning of a paper, things which need a lot of energy to be brought about and also cannot be reversed easily, they are chemical changes. Okay, so in chemical changes, you cannot get back the original thing easily. Here in physical change, you can get back the original change or original substance. So composition of the water remains water only, whether it is in the vapor state or it is in the state of liquid or it is in the solid state in the form of ice, it will remain water. Whereas in chemical changes, it changes completely. We are burning paper, so from cellulose it changes to carbon completely. Okay, and so it is not reversible. Okay, here only change in physical properties happen. Okay, first point. Second point, change in chemical property also happens. Change in chemical property happens. Okay, next, this is a reversible change. Okay, we can easily reverse it. This is a non-reversible change. Non-reversible change. You can't change it easily. Now this one, but there is one very important, as I told, growth of a tree, chemical. Okay, if I say digestion of food, chemical. But then one thing which you can, and boiling of water, melting of ice, condensing of water, everything is a, even sublimation is a physical change. Okay, now here if I take, melting of wax, mistakes can happen in this. Melting of wax is a physical change because the molten wax will solidify and again form solid wax. Here candle burning of candle okay, burning of candle is a physical change, a chemical change completely, because when candle burns you can't get back the wax anymore, it is gone. Okay, so when candle burns you get back only, it converts into carbon dioxide and water vapor, so it is completely gone. So when a candle burns, two things happen. One is melting of wax also happens, along with burning of wax. Some wax is burning, some wax you'll see is melting and falling at the sides. So burning of a candle is an example of physical and chemical change together. So that was it in physical and chemical changes, and is matter around us pure, this chapter. Okay, so I have another video where I have done suspensions, colloids and solutions and their properties in detail. Okay, so if you have liked the video, do not forget to like, share and subscribe. Also, you must also leave a comment. Okay, if you are liking the video, I would love to see your comments. Please comment. You'll find many more videos in the playlist. Please check the playlist. You'll get lots of videos of 9th standard science, physics and chemistry, and also maths. There are separate playlists for that. Thanks all of you. Thanks for watching. Bye bye.